So we have this orbit here. We have a star here, a star here. So this is the force of gravity, and this is the force of gravity. So, and we have this distance here being defined as d. A asks why the two stars don't crash into each other. The two stars don't crash into each other because they're in circular motion. So undergo uniform circular motion and the gravitational force is centripetal and maintains that motion. Maintains this motion. So at this point, if the gravitational force is centripetal and maintains this motion, they're not going to crash into each other. This is why, because if they're perfectly on the opposite sides of this this orbit here, that means that their force of gravity is always going to be parallel but opposite to one another, and they're going to keep themselves in this loop forever, given that they're undergoing uniform circular motion, and that gravitational force always stays centripetal, which indeed it will. However, it is important to note that they're undergoing uniform circular motion. So if the stars were to ever come to rest, if the stars ever came to rest, they would then crash into each other. And so that would be your answer for part A. For part B, we need to find the mass of one of these stars. So we know that the velocity is going to be equal to 2 pi r divided by t, and we know that this is going to be equal to pi times the diameter, or rather pi times d divided by t, that distance between the two stars. We know that the force of gravity is equaling to the universal gravitational constant times the mass of the stars squared divided by d squared. And we know that this is going to equal the radial force, and this will equal mv squared over r, or mv squared over d over 2. So we can say that this is going to be equal to 2m pi d over t squared over d. And so we can say that g m squared over d squared is going to be equal to 2 pi squared md over t squared. And if we're trying to find m, we can simply say that m is going to be equal to 2 pi squared d cubed divided by gt squared, and we can solve directly now. So 2 pi squared times d, so 8 times 10 to the 11th cubed divided by 6.67 times 10 to the negative 11th. And then t squared would be 12.6 years. And then there are 3.15 times 10 to the 7th seconds for every year. And then we're going to square the period as well. So this will going to be equal to 9.6 times 10 to the 29th kilograms. So this would be the mass of each of the stars. That is the end of the solution. Thank you for watching.